Now in this problem, to define the function, the expression which is under the root sign has to be greater than or equals to 0. That is, let me just factorize the expression. So we are getting, now from the number line we can say, therefore we can write, now we all know that fractional part of x always lies between 0 and 1. Therefore, fractional part of x is greater than equals to 1. This inequation has to be rejected. So we are left with fractional part of x is less than equals to half. That implies x is either lying between 0 and half, or x is lying between -1 and -half. As we have been given that x lies between -1 and 1, therefore the range of x cannot be less than -1. Is it clear? Therefore our answer should be this part only. Now observe one thing, that your fractional part of x is less than equals to half means your fractional part of x can be equals to 0 also. Now fractional part of x is equals to 0 when x is an integer. Now within this given domain, if x takes the value 1, then your fractional part of x becomes 0, which definitely satisfies this inequation. Therefore the required domain will be, is it clear to all of you? Have you understood the problem? Okay, let us move for the next one. Now, in this problem, to define the function, the denominator cannot be equals to 0. That is, so we can say, is it clear? Now we have to define 3 sections. One is when x is less than 2. We are now not considering the borderline cases. We will check it later on. When x is less than 2, then, is it clear? Now you observe, we know that box of x plus any integer can always be written as box x plus integer, right? So from here we can write, so we can say, that implies, now when x belongs to an integer but less than 2, when x belongs to an integer, we know that when x is an integer, box of minus x can be directly written as minus of x. Therefore, minus of x is not equals to, sorry, it will be not equals to minus 2. That implies x is not equals to 2. This is the first thing that we got, that x cannot be equals to 2. Now when x does not belongs to an integer but less than 2, in that case, box of minus x can be written as minus of box x minus 1. Therefore, box of x is not equals to 1. That implies x does not belongs to closed 1 open 2. Is it clear? Therefore, when x is less than 2, in that case, the function will be defined, that is, this portion will never be equals to 8 when x belongs to from minus infinity to 1. Is it clear? Both sides open. Have you understood till this? Okay. Now, number 2. When x is lying between 2 and 10, in that case, this equation becomes Now again we will consider that when x belongs to an integer, but between 2 and 10, in that case, your box x will be written as x only and box of minus x will be written as minus x only. So which is not true. 0 is not equals to 0 is not true. Is it clear? Therefore, in this range, your x cannot take any integers. That is, x should not take the integers. Is it clear to all of you? Okay. Now, when x does not belongs to an integer, again within this range, in that case, and which is true, minus 1 is not equals to 0. Therefore, we will say that within this range, that is from 2 to 10, x can take any non-integral values, right? Therefore, from here we will say that x will not take the integral value between 2 and 10, but it can take any non-integral values between 2 and 10. Is it clear? Now let us move for the last case. When x is greater than 10, in that case, this one becomes, that implies box x cannot be equals to 10 implies x does not belongs to 10 closed, 11 open. But in this case, since we have not taken the borderline case, so from here we will say that x does not belongs to 10 to 11. Is it clear to all of you? Have you understood it? Okay. Now, for this range, when x is greater than 10, your x can take any value other than the values within the range 0 and 11. Is it clear to all of you? Now let us consider the borderline cases. If x is equals to 2, then this one becomes, look it very carefully, this one becomes box 0 plus box of 8 is not equals to 8. That implies 8 is not equals to 8, which is not true. Therefore, x cannot be equals to 2, right? We also got it from here. But still, since in this case we have not considered the borderline cases, that is why I am showing you separately. Now, when x is 10, then again this equation becomes, what it will become? Box of 8 plus box of 0 is not equals to 8. That implies 8 is not equals to 8. Again, this is not true. Hence, x is equals to 2 and x equals to 10 we will not consider. Have you understood it? Therefore, our final domain will be x belongs to any real value except so this is the required domain. Have you understood it? Absolutely. You have to practice this sum by your own. Then only you will understand it completely. Because this sum is little difficult from the sums that we have done previously. Okay, let us move for the next problem. In this problem, to define the function, the expression within the root sign of fx, that is log gx base phi x, has to be greater than or equals to 0, right? Now we have been given that gx equals to mod of sin x plus sin x. Now as they have given that x is lying between 0 and pi, so mod of sin x can be simply written as sin x because in the first and second quadrant sin x is positive. So gx is nothing but your 2 times sin x. and phi x equals to sin x plus cos x, which can also be written as root 2. Now, if I replace this 1 by root 2 by cos pi by 4 and this 1 by root 2 by sin pi by 4, this will become, is it clear to all of you? Have you understood it? Okay. Now, to define the function, first thing is that your log gx base phi x has to be greater than or equals to 0. Number 2, gx has to be greater than 0 because within the log, the expression cannot be negative. Third point, phi x has to be greater than 0. And the last one is phi x cannot be equals to 1. So these are the points, these 4 points we have to consider to define this function. Is it clear? Now you see, phi x is greater than 0. We are considering this part. Phi x is greater than 0 implies what? This is greater than 0. That implies, is it clear? Now you observe, we have been given that x is lying between 0 and pi. Therefore, x plus pi by 4 lies between pi by 4 and 5 pi by 4. Is it clear? Now, within this range, sine is positive when this is greater than equals to pi by 4 and less than pi. Is it clear? When this angle is lying in the first and second quadrant only, then your sine is positive. So from here we are getting that x is lying between 0 and 3 pi by 4. Is it clear to all of you? Have you understood it? Okay. Now, let us consider this portion where it states that phi x cannot be equals to 1. That implies see one thing, sine of x plus pi by 4 is 1 by root 2. Tell me, within this range, that is from pi by 4 to 5 pi by 4, where your sine theta is 1 by root 2. It's simply when it is pi by 4, or it can be when x plus pi by 4 is 3 pi by 4. Is it clear? That implies x cannot be equals to 0 or it cannot be equals to pi by 2. Is it clear? Now, if we combine this and this, we are getting our answers from these two conditions. We are getting our answer as x is greater than 0, less than 3 pi by 4, except pi by 2. So please remember this. Is it clear? Okay. Now let us come for when gx is greater than 0. That is, we are considering this condition, right? Gx is greater than 0 means 2 times sin x is greater than 0 implies sin x is greater than 0. Now you observe, as x is lying between 0 and pi, your sin x is greater than 0 means your x lies between 0 and pi. Hello? Because as x is in the first or second quadrant, hence sin x will be positive, excluding 0 and pi, because at x equals to 0 or at x equals to pi, your sin x will become 0. So we have to exclude those points. That is why I have written x belongs to open 0 to open pi. Is it clear? Now let us come to the last point where, is it clear? Now you observe, gx can be written as phi x to the power 0, or it can be written as, is it okay? Now the question comes, when to write this condition and when to write this condition. Very clearly we know that log of a by b, if it is greater than 0, then a will be greater than b to the power 0 when b is more than 1 and a will be less than b to the power 0 when b is lying between 0 and 1. Is it clear? Now the question comes, this condition is satisfied when phi x is more than 1, and this condition is satisfied when phi x is less than 1. Is it clear? Now you see, we got that x is lying from 0 to 3 pi by 4 excluding pi by 2. Now observe it carefully. X plus pi by 4 in that case will lie between pi by 4 and pi. Is it clear or not? Right? Now excluding 3 pi by 4. Excluding 3 pi by 4. Now when x plus pi by 4 is lying between pi by 4 and 3 pi by 4. Look it very carefully. In that case, root 2 sine x plus pi by 4 will be greater than equals to 1. Hello? Yes or no? Is it clear? So in that case, that is within this range, this condition will satisfy. And when x plus pi by 4 belongs to 3 pi by 4 and pi, in that case, root 2 sine x plus pi by 4 will be less than 1, greater than 0, definitely. Is it clear or not? Have you understood it? Okay, so in that case, we will apply this condition, right? Let me rub the upper portion. So now, when x plus pi by 4 is lying between pi by 4 and 3 pi by 4, that is, x lies between 0 and pi by 2. In that case, we will write gx is greater than equals to 1. That implies 2 sin x is greater than equals to 1 implies sin x is greater than equals to half. So from here we can write x belongs to, because half will give you actually sine 30 degree, right? So from here we will write that x belongs to closed pi by 6 to pi by 2 open, because our range of x in this case is from 0 to pi by 2. Is it okay? Now let us consider the second case. That is when x plus pi by 4 belongs to 3 pi by 4 to pi. In that case, your x belongs to pi by 2 to 3 pi by 4. Is it clear? In that case, your gx, because this condition will be satisfied in that case, your gx is less than equals to 1. Is it clear? That is, 2 sin x is less than equals to 1 implies sin x is less than equals to half. Now from here, we are not going to get any set of values of x, because as x is lying from pi by 2 to 3 pi by 4, in this region, your sin x will never be less than or equals to half in this region. Therefore, from this region, we are not going to get any solution. Therefore, the required domain for this function is closed pi by 6 to pi by 2. Have you understood this problem? Absolutely. Okay, let us move for the next problem. In this question, we have to solve the given two equations. We have been given that y is 1/3 box of sin x plus box of sin x plus box of sin x. Have you understood why I have written it so? Because we know that box of x plus any integer can be written as box of x plus integer. Now, box of sin x plus box of sin x, look it carefully, this one is an integer. So you can write this thing as box of sin x that is box of x over here, and integer you separate it out. So it will be again box x, because box of sine x itself is an integer. So I have separated it. Okay. So from here we are getting 2 box of sine x, right? Again, this one is an integer. So you can write this thing as box of sine x plus 2 box of sine x. Is it clear or not? Since this is an integer, I have separated it out. So it can be written as 1/3 into 3 times box of sine x, which is nothing but your box of sine x. So from the first equation we got that y is nothing but box of sine x. Is it clear? Now from the second one we are getting, again with the similar reason, we can write box of y plus box of y will be equals to 2 cos x. Therefore 2 box of y will be 2 cos x, implies box of y will be equals to cos x, right? Now you observe, if y equals to box of sine x, then box of y will be what? Hello. It will be box of sine x, which is nothing but your box of sine x again. Is it clear? So we can write box of y equals to cos x, and box of y again it is equals to box of sine x. So we can write this thing as box of sine x is equals to cos x. Is it clear? The solution for this equation, all we do is we take y equals to box of sine x and y equals to cos x. Now the points where these two graphs will intersect each other will be the solution for this equation. So first of all, on the same graph paper, we have to draw the graph of y equals to box of sine x and y equals to cos x, and there we will find out at what points they are intersecting. Is it clear? So I will draw the graph of y equals to box of sine x. Now to draw the graph of y equals to box of sine x, first thing that we have to remember is box of sine x is a periodic function with period 2 pi. So we will draw the graph of y equals to box of sine x from 0 to 2 pi, and then we will repeat the same graph. So in this case, when x is greater than 0 and less than pi, except pi by 2, look it carefully, then your sine x is lying between 0 and 1. Is it clear? When x is 0, sine x becomes 0, eventually box of sine x will be 0. When x is pi, again your sine x will become 0, so box of sine x will be again equals to 0, right? But when x is pi by 2, we are having sine x as 1. Therefore, box of sine x will be 1 in that case, right? So let me draw the graph from 0 to pi of y equals to box of sine x. We get when x is 0, box of sine x is 0, so this point is closed. When x is pi, box of sine x is again 0, so this is again closed. But at pi by 2, it is open, right? This is pi by 2. So the graph is from 0 to pi by 2, then from pi by 2 to pi. But at x equals to pi by 2, the value is 1. Is it clear or not? So this is the graph of y equals to box of sine x from 0 to pi. Now, when x is from pi to 2 pi, then what will happen? In that case, your sine x lies between -1 and 0. Is it clear? When x equals to 3 pi by 2, look it carefully, then your sine 3 pi by 2 will give you -1. Therefore, in that case, your box of sine x will be -1. Is it clear? Therefore, from pi to 2 pi, box of sin x is nothing but -1. Is it clear? When x equals to pi, we got that box of sin x is 0. When x equals to 2 pi, sine of 2 pi is 0. Hello? Sine of 2 pi is 0. Therefore, box of sin x in that case, when x is 2 pi, will be equals to 0. Therefore, the graph of box of sin x from pi to 2 pi will be like this. This is 0. This is pi by 2. This is pi, right? This is say 3 pi by 2. And this point is say 2 pi. Therefore, the graph of the equation will be pi it is open, 2 pi it is open, and at 3 pi by 2 we are having -1. So, box of sin x will be also -1 in that case. So, the graph will look something like this. Is it clear? So, this is the graph of y equals to box of sin x when x is lying from 0 to 2 pi. Now, you can repeat this graph throughout. Now, let me draw the graph of y equals to cos x. Y equals to cos x will be like this. At x equals to 0, it is 1. Then it is coming down. At pi by 2, it will come here. Then pi, it will be here. Then again, it will move up. At 3 pi by 2, cos x is 0. And at 2 pi, it will be 1 again, right? Now, within this range, you can see easily that nowhere these two curves, that is y equals to box of sin x and y equals to cos x, is intersecting. So, throughout the graph, if you draw it, nowhere it will intersect box of sin x. If you draw the graph of cos x throughout, it will never intersect y equals to box of sin x. Is it clear? Therefore, from here we can write that we are not going to get any real solution. So, no solution is possible for this simultaneous equation given to us. Is it clear to all of you? Let us move for the next problem. Now, in this problem, we have been given that box x equals to, from here we can write, now in place of x, you write n. In this equation, in place of x, you write n. So, we are getting, in this equation, you write, in place of n, you write n by 2. So, we are having, after simplification, again in this equation, you write n by 2 in place of n, we are getting, again in this equation, you write n by 2 in place of n, we are having, and this thing goes on. So, the nth term, the right hand side of the nth term will be, now if I add the corresponding sides, in the left hand side we are going to have, and in the right hand side, if you observe, you will find that these terms will get cancelled. So, this term will also get cancelled with the previous term. So, we are left with, now as n is a positive integer, 2 to the power n is always greater than n. Therefore, n by 2 to the power n will be less than 1, right? Hence, this term will become 0. So, we are left with box n only. Now again, n is a positive integer, so it can be written as directly n. Is it clear? Hence proved. Is it clear to all of you? Let us move for the next problem. In this problem, we are having two parts. First of all, we have to find out the integral solution for the equation box x into box y equals to x plus y. Okay, that we are doing first. And then we will show that the non-integral solution of this equation will lie exactly on two lines, and we will find out the equation of the lines. Is it clear? So, the first of all, we are finding out that what will be the integral solution for this equation. We know that x can always be written as box of x plus fractional part of x. Therefore, so we are having, now let me add 1 in both sides. We are having left hand side can be factorized as, now you observe, if x and y are two integral values, then fractional part of x will become 0 as well as fractional part of y will become 0. Therefore, the equation becomes, for integral values of x and y, it is possible when, or, so from this we are getting, that implies x is 2, because here we are taking the integral values of x and y. Similarly, we are getting y as 2, and from this part we are having, so for the integral values x will be 0 and y will be 0. Therefore, the integral solution 0, 0 or 2, 2. Is it clear? Now, let me just do the next part of this sum. Now, x belongs to non-integral values. In that case, your fractional part of x will lie between 0 and 1. Fractional part of y will lie between 0 and 1. Therefore, fractional part of x plus fractional part of y will lie between 0 and 2. Thus, is it clear? Now, from the equation, fractional part of x plus fractional part of y plus 1 is basically an integer, right? Therefore, this value can take only the integral value it can take it as is 2. Because between 1 and 3 we are having only one integral value which is 2. That implies fractional part of x plus fractional part of y is 1. Is it clear? Now you observe, your equation becomes, have you understood it? Is it clear? Now, it is possible only when, because you see, this is an integer, this is an integer. It is possible only when or have you understood it? Now, from the first one we are getting, this implies x lies between 3 and 4, y lies between 2 and 3. From the second one we are getting, is it okay? From the third one we are having, and from the fourth one we are having, is it clear? Now please consider this portion. When x belongs to 3 to 4, your fractional part of x can be written as x minus 3. And when y belongs to 2 to 3, fractional part of y can be written as y minus 2. Therefore, this equation becomes, so from here we are having, so this is the required line. Is it clear? Where the non-integral solution of the given equation lies. Now let us consider the second part. As x belongs to 2 to 3, your fractional part of x can be written as x minus 2. And as y belongs to 3 to 4, your fractional part of y will become y minus 3. Therefore, again, from this equation, we are having the same equation, right? Let us consider this portion. Your fractional part of x in this case will become x plus 1, and fractional part of y will become only y in this case. Therefore, the equation becomes x plus y equals to 0, correct? Move for the last one. X belongs to 0 to 1, so fractional part of x can be written as x only, and fractional part of y can be written as y plus 1. Again, from this equation we are having x plus y equals to 0. Therefore, the required two lines are x plus y equals to 6 and x plus y equals to 0. These are the required two lines where all the non-integral solution of the given equation lies. Is it clear? For the integral solutions, the solution is 0, 0 or 2, 2. And for non-integral solution, it lies on two lines, x plus y equals to 6 and x plus y equals to 0. Is it clear to all of you? Okay.